Hey guys, so we are working on finding the resultant of two vectors. And last time we learned, a resultant is when you add two vectors together. It's also called the vector sum. And we made some graphs, put some vectors on there, and found the resultant graphically, which is great. But we're also going to want to be able to put some numbers to this, how much is the resultant and in what direction exactly is the resultant. And so today we're going to talk about adding those vectors together algebraically, and we're going to talk about vector operations. So as we talk about adding vectors algebraically, there's a couple of mathematical tools we need to keep in mind. And we've all taken geometry, so I know we already know these tools, but let's just kind of refresh them real quick because we're going to need to use them to add these vectors together. One of them is what's called the Pythagorean theorem. I'm sure everybody knows the Pythagorean theorem. It's a very famous theorem. C squared equals a squared plus b squared. And keep in mind, Pythagorean theorem only works for right triangles. So in a right triangle, c squared, the length of the hypotenuse squared, is equal to a squared plus b squared, the sum of the squares of the other two sides. When two vectors are perpendicular, we can easily use the Pythagorean theorem to find the length of the resultant. The resultant will be the hypotenuse, right? So we can easily use the Pythagorean theorem to find the length of the resultant. And later on, we're going to learn to resolve vectors into perpendicular components, which will make the Pythagorean theorem useful in pretty much any case. So even if your vectors are not perpendicular, we'll still be able to use it to add the vectors together. The other mathematical tool from geometry we kind of need to keep in our heads is the tangent function. And I'm sure everybody loves their trigonometry, right? Remember, trigonometry works in right triangles. So, the tangent function comes from a right triangle. And the tangent of an angle is the opposite side over the adjacent side. And, if we're thinking about a vector in a coordinate plane, which is a really convenient way to think about it, we can easily describe its direction with an angle. So the tangent function will help us find the direction, the angle of the resultant vector. So in order to find that angle, we're usually going to want the angle and not the tangent of the angle. So we're going to end up doing the tangent inverse to find the angle. So two things to keep in mind: the Pythagorean theorem and the tangent function. Those are going to help us to find the resultants of our vectors. Okay, let's look at a problem and we'll see how to go about using these to find the resultant of two vectors. The problem we have in front of us here: an archaeologist climbs a pyramid with a height of 136 meters and a width of 2.30 times 10 to the second meters. What is the magnitude and direction of her displacement when she reaches the top? Okay, probably a good strategy for approaching this problem and any problem involving vectors is to draw a little picture to help us out to start with. So hopefully a little picture right here will help us kind of understand what's going on in the problem. So the first vector represents her displacement kind of in the horizontal direction, in the x direction. And the top of the pyramid is only halfway across the width of the pyramid. So, it gives the width of the pyramid as 2.30 times 10 to the second meters. But really what we want is just half of that to the middle of the pyramid, because that's where, the high point is. So 2.30 times 10 to the second meters, that's 230 meters with three significant figures. So I want just half of that. So half of 230 is 115 meters. So the first vector is entirely in the horizontal direction, entirely in the x direction, is 115 meters. The second vector represents her displacement kind of in the upward direction, maybe in the y direction you want to call it, right? And that's equal to the height of the pyramid. The height of the pyramid is 136 meters. So you can see the first vector is horizontal in the x direction, 115 meters. And the second vector, which will line up right at the end of the first vector, is 136 meters, straight up. So there's your two vectors that we're going to add. And you can see in the picture, the resultant is this line labeled D. The resultant is that line labeled D, and its direction is that angle theta. So we need to find the length of D and the angle theta. Well, that should be fairly easy to do. It's a right triangle already, so it's a nice easy problem there. So we're going to use the Pythagorean theorem to find d, which is the length of the vector, the magnitude of the vector. So c squared equals a squared plus b squared, and looking at my diagram there, I can easily tell that a and b should be 115 and 136. Does it matter which is a and which is b? Absolutely not. You can switch them, that's fine. So c squared equals 115 squared plus 136 squared. And then what I'm going to do is I'm going to get my calculator and work out what's 115 squared plus 136 squared. And my calculator tells me that is 3.17 times 10 to the fourth power to 3 significant figures. And then, of course, since that's c squared, I want to take the square root. And the square root of that number should come out to 178 meters. So there is the magnitude of the vector. That's how long the vector is, 178 meters. So I can say that this archaeologist going up the side of the pyramid has traveled 178 meters. But in what direction did she go? That's where we want to find that angle that's labeled theta there. So I can look at the diagram and I can tell that the tangent of that angle, the tangent of theta, would be the opposite side over the adjacent side. The opposite side, the side opposite from theta, is 136, and then the adjacent side, the one next to theta, is 115. So the tangent of theta is 136 over 115, and then I'm going to do the tangent inverse of both sides, because I'm not interested in the tangent of theta, I'm interested in theta. So I'll do the tangent inverse of 136 over 115, which if you punch that in your calculator, now be careful, those of you who are in math class might be working in radians instead of degrees. Make sure your calculator is set correctly. But when I type that in, my calculator is set to degrees, I get 49.8 degrees. So I can put those two together and I can answer the question. So they asked me, what is the magnitude and direction of her displacement? I'm going to say it was 178 meters at an angle of 49.8 degrees to the horizontal. And it's kind of important to say what your angle is with respect to there, right? We're measuring our angle with respect to the horizontal. Usually, if you're working in a coordinate plane like this, it's with respect to the x-axis, with respect to the horizontal. So there's an example. So keep in mind, we can use these tools when we're working with vectors that are perpendicular to each other, right? Next time, we'll talk about how to resolve vectors into their perpendicular components so that we can apply these same ideas to vectors that are not perpendicular. And then we'll be able to find the resultant of really any two vectors, regardless of whether or not they're perpendicular. So, hopefully that gets us a little bit closer to being able to find the resultant of two vectors.